Hi, my name is Cindy. I work for CSIRO. I led the methane and greenhouse gas studies for the Beetaloo sub-basin. Um, I live in Perth, and hence I would like to begin by acknowledging the Whadjuk people of the Noongar Nation as the traditional owners of the land that I'm speaking from today, and pay my respect to their elders past and present. So what is a baseline study for greenhouse gas or methane? So as part of the Northern Territory Fracking Inquiry recommendation, um, the the definition or the requirements for a baseline study for greenhouse gas basically said baseline information to enable the assessment of regional and cumulative effects of onshore gas development across the region. So a Schreiber framework or guidance notes on greenhouse gas was actually developed as part of that. And they are actually 6 indicators. I'm not going to read them all out, but basically you can see that there are 6 indicators that we are actually trying to satisfy in this work. So the scope of work that we did, the work that we did covered the baseline, using a baseline mobile survey covering the dry, fire, and wet period. What I mean by a mobile survey is basically what we have is a vehicle like the picture that you see on the screen. We have up to three gas analyzers on board measuring methane, ethane, and sometimes 2 times methane as well. And so the other thing is that we have climate data. That is the thing here that you see on top of the vehicle, and what we then measure is the wind direction and wind speed, which is the most important thing. The concept is that we have the air intake into the gas analyzer into the which are located in the vehicle, and we drive around capturing information about greenhouse gas, specifically methane, across the region. And we did this in the dry, fire, and wet period, as I said. The other part, the second part of our project was identifying where geological seeps could be and potentially doing measurement there, and also doing reference or putting out reference sites across the area, which is not or which is a site which are not going to be affected by or impacted by industrial development. The third part of our work is collating information produced by the Northern Territory, national programs, and other researchers related to greenhouse gas in the study area. So I'm going to talk a little bit about the results of our work. Um, First, I'll talk about the mobile survey. This picture or this map that you see on the right-hand side is the data that we collected for the mobile survey during the fire season. This is the first map. The second map that you see here is the data that we collected during the wet season. And you will see that we have a reduced number of, so I forgot to say that the colors basically is where we have collected the data. So basically where they are, so the range goes from blue to purple, depending on the levels that we measure. So in the wet season, obviously we cannot actually go on some of the roads or tracks, and so that's why there's a reduced number of colored areas that you see. So the last survey that we did was in the dry season in June 2022. We covered quite a lot of area, very similar to the first survey, which was the fire survey. out of all those surveys, we then are able to understand what the background or the ambient methane concentrations are across the different seasons. And what we found is that the levels, or the background methane concentrations across the study area are comparable to a national reference site called Cape Grim in Tasmania. However, we actually did some work previously, which was also collecting mobile survey baseline data or background data in 2018 and 2019. The levels that we measured during the study was actually higher than 2018 and 2019. And the difference actually is aligned with the reference site or the national reference site in Cape Grim. So basically, the increase is actually similar to what's happening nationally. And what we found in this work with the mobile survey is we've identified some of the main sources of methane emissions, including, like it's one of the largest industry, I guess, in that region right now, or that study area right now is cattle. So we obviously we were detecting quite a lot of cattle, but at the same time, we were also detecting things like the different towns. And you will see here on the road, we were detecting some, there could potentially be other vehicles. These are cattle on these kind of areas here. But the other thing that we did detect, which was quite interesting, is a potential leak from a plug and abandoned well or water bowl, because there were three overlapping things in the area that we measured, and we need to actually try and identify what they are. And in the, that's one of the recommendations that we have, is to look into that well further. So we, as I said before, we actually collated information from data that was sourced from other NT researchers, as well as some of the NT programs and national programs, to understand better the main sources of methane in the region. So basically what we are trying to get at is to develop an inventory of the main sources. So the region, the main industry is cattle. And so we source the cattle number for the region, or more updated cattle numbers in the region. And we estimated a total of 51,600 tons of methane per year. And then you will see, or as you saw on my covering slide, the study area has quite a bit of termite mounds in the area. Termite is one of the largest sources, or one of the sources of methane. We estimated from studies that some of the CSIRO colleagues have done, that there is something like 2,800 tons of methane per year produced by termites. Fires, as I said in the mobile surveys, we actually, did a mobile survey during fire. That's because we know that fire is one of the main sources of methane in the study area as well. With some of the studies that some of our colleagues did, we were able to then estimate the amount of fires, or the emission rates related to fire. There's 5,000, roughly about 5,400 tons of methane per year. The Elliott Power Station is a source of CO2, obviously. They are running the energy source of the Elliott Power Station is actually, I think, diesel, and so it is producing something like 2,100 2,155 CO2 equivalent per year. tons, sorry. And Daily Waters has another power station. It produces 1,104 tons of CO2 equivalent per year. For soils, soils is known to be a sink, a very good sink of methane, and one of the only natural sinks of methane. With the work that some of the CSIRO colleagues have done, we were able to estimate how much of a sink it is. We estimated that it is actually 13,125 tons of CH4 or methane per year. So we talked about that one of the focus areas is to find some of the natural geological seeps of methane and understanding using the geological information. One of the areas that have been identified as a potential geological seep is the hot springs near Clean's Gorge. We finally managed to go to this site at the end of our study area. We did atmospheric measurement, or we used a methane analyzer, methane ethane analyzer, to measure the methane and ethane close to one of the bubbling hot springs. So we found that the methane and ethane were correlated close to these bubbles at the hot springs. Usually, if it was at a site where we know industrial development is happening, for example, at um, a well site, a correlated methane and ethane signature indicates that it is a thermogenic source or a source that's related to the industry. However, in this situation, we know that there is actually biogenic or biological sources of ethane at some hot springs as well. So this is the other bubble area that we measured. And again, we see correlated methane and ethane at that bubble area. So we need to investigate this further to understand whether this, where the source of this methane and ethane is coming from. So the third thing that we did was to actually deploy a automated monitoring station. You see this on the right-hand side where we have a methane analyzer and some climate data being collected fully automatically powered by a solar panel, as you see on the side. This was actually located at a reference site where we know that there are very little impact or anthropogenic impact. And the idea is to actually collect background data that is not contaminated by any anthropogenic activities. So you see some of the data that we collected on the left-hand side. The good thing is that we were able to demonstrate with this deployment that we were able to sustain, like sustainably deploy this monitoring station over an extended period. I think we were able to deploy it over like something like a 9-month period without any break in data. So that's quite good. The only breaks that we have in the data would be when there wasn't enough sun. You will see that on the side there's quite a lot of vegetation, so shading obviously obscure the energy that the solar panels is able to get, and sometimes we would run out of power just solely because there's not enough sun on the panels. So I'm actually nearly to the end of my presentation. Some of the results and recommendations for the future work that should be done in terms of the monitoring. We think that with with future development, we should continue doing regular mobile surveys, especially around development sites, to better understand new or unknown sources. Once we if we do actually detect or locate any new sources, we recommend that quantification of the emission rates be done. The autonomous monitoring station at the reference site, we believe that should be kept so we can actually at least monitor what the background level is. So if there are any differences, we can understand what the levels are. And also targeted deployment at any geological seeps to understand if those seeps what are the natural variation and temporal variation, and if there are variation, are they real? Are they related to anthropogenic activities? What are they related to? And also, in the end, also the whole idea is to understand how big are these sources, and the way we understand how big are these sources is to quantify the emission rates. Um, One of the things we found with and this is a more or less a national thing, is that combustion sources like power stations don't actually measure methane, or it's not part of the compliance requirement. And one of the things that we would recommend is to enhance the compliance monitoring of combustion sources to actually measure methane as well, and other relevant greenhouse gas if possible. So, in terms of research and collaboration in the future, extending from the work that we've done, I spoke a bit about the bubbles at the hot springs, and that we didn't really understand that what the sources are. This is something that we believe we should pursue, or further research and development in the future, because to understand, it is necessary to understand what these sources are, where it came from, whether it's actually connected, where is it connected to, so that we can see whether it's related to a thermogenic source or it's just biological. And some of the ways that you can actually understand the source is by doing further studies, such as isotopic studies, to understand the origins of the methane, ethane, and any other associated gas, which will allow us to understand what the origin of the sources are. And if we then see that the sources could be thermogenic, continuous monitoring of the SIPs would be quite important. Really, it is one of those things where, if they are sources that would be useful to look at. In terms of the autonomous monitoring station, we have demonstrated that we can actually deploy it for extended periods. So there are potential to use this kind of technology to monitor the industrial development themselves. Um, for example, they could be put out at large industrial development, let's say a gas processing facility. And also, as I say, we recommend actually putting one out at a reference site, so that you can have an indicator of the difference. Um, Monitoring of industrial development is really quite important. And one of the things that we would recommend is to actually look into leak and detection repair protocols. And I think, they right now, with the changes in technology, what we've done in previous work is that we found that there is reduced amount of leaks, and so update of technology to allow people to detect some of the leaks is quite important, and update of the protocols with those is quite important. One of the things that I have been asked to speak about is remote sensing and the role of remote sensing, mainly because I'm a remote sensor as well. Um, I think right now, the greenhouse gas satellite, they are quite a few greenhouse gas satellite that are being proposed, um, and and will be launched in the very near future. There's a lot of talk about it. I think that we should be monitoring the progress of greenhouse gas satellite. However, for baseline studies, though, currently the greenhouse gas type satellites are limited to super emitters. These are, uh, sites that actually are already anthropogenic or big emitters, much bigger than the levels that we require for baseline study, and really a lot of them would be much bigger than any of the ones that we see in Australia. So we could improve the other role of other type of satellite data or remote sensing is to use them to improve the estimation of, let's say, other things, like, for example, we could use them to estimate or have better estimates of the composition of the vegetation, which actually then goes into the input of the fire estimate. That's one of the potential areas that you could look at. You could use it to extend the spatial extent of vegetation mapping. You could use it for particularly now with the you know next generation or optical satellite, which is really my field of imaging spectroscopy. You could use the data for very specific diagnostic things, such as soil parameters, soil mineralogy, dust, where does the dust come from through the mineralogy. And I think that actually brings me to the end of my presentation. Thank you. And I'd like to also thank the people who work with me in the team. Obviously, there's myself, there's Charles Heath, Dave Down, Medrick Manson, Michael Cacetta, Bruce Bainey, Emma Ferry, Yelena Markov, and from the department, NT department, it's Dave Wilson. Thank you very much.